tonight I want to open a case file. It begins with a measurement so unsettling that when astronomers first confirmed it, some of them simply did not believe it, and it concerns you, personally, at this exact moment. You feel still. Your bed is not moving, your room is not moving. And yet, right now, you, your bed, your home, the earth beneath it, the sun above it, and the entire Milky Way galaxy around it, all 400 billion stars of it, are plunging through space at more than 2 million kilometers per hour toward a single point in the southern sky. 2 million kilometers per hour. That is 600 kilometers every second. In the time it took you to read this sentence, you traveled farther than the distance from New York to Tokyo, in a direction you have never once thought about, pulled by something you have never seen. And here's what turns this from a curiosity into a genuine mystery, the kind that consumed careers and started scientific arguments that lasted decades. Whatever is pulling us must be one of the largest concentrations of mass in the known universe, powerful enough to drag hundreds of thousands of galaxies toward itself across hundreds of millions of light years. An object like that should be impossible to miss. It should blaze in our night sky. And yet, when astronomers turned their telescopes toward the point we are falling toward, they found, at first, almost nothing. The thing pulling the Milky Way was hiding. And the place it chose to hide is the single most frustrating hiding spot in the entire universe, for a reason that is almost comically unfair, and that I promise will make you smile when we get there. Astronomers gave the culprit a name before they ever saw its face. They called it the Great Attractor. Tonight, we are going to work this case the way it was actually worked, clue by clue, suspect by suspect, wrong turn by wrong turn, across 40 years of investigation, until we arrive at the answer modern astronomy gives, an answer that turns out to be bigger, stranger, and more beautiful than the mystery itself. Because the truth is not just that something is pulling us, something else, on the opposite side of the sky, is pushing. Before we open the file, if you enjoy these long, deep investigations into the universe, a quick like or subscribe genuinely helps this channel grow. It is a small thing for you, and it makes a huge difference for me. Now, let's begin. Every good investigation starts by establishing the facts. So our first task tonight is to answer a question that sounds simple and is actually one of the deepest in physics. How do you measure the speed of a galaxy when you are inside it? Think about the problem. Speed is always measured relative to something. A car's speed is relative to the road. A plane's speed is relative to the ground or the air. But the Milky Way is not driving on a road. Space has no milestones, no signposts, no painted lines. If two galaxies drift past each other in the void, each is entitled to claim it is the still one and the other is moving. So when I tell you the Milky Way is falling at 600 kilometers per second, you should immediately ask, relative to what? And the answer is wonderful, because the universe, it turns out, does provide one reference, exactly one, and it is the oldest thing that exists. It is the afterglow of the Big Bang itself. When the universe was young, hot, and dense, all of space glowed. As the cosmos expanded and cooled, that glow faded and stretched, and today it survives as a faint bath of microwaves arriving from every direction in the sky. The famous cosmic microwave background. You have heard of it, perhaps, as a baby picture of the universe, and it is. But tonight it plays a different role. Tonight it is a speedometer. Because the glow comes from everywhere, it defines the one frame of reference that belongs to the universe as a whole, the frame in which the afterglow looks the same in all directions. And when our satellites measured that glow with precision, they found it is not quite the same in all directions for us. In one half of the sky, the microwaves arrive very slightly warmer, their waves compressed. In the opposite half, very slightly cooler, their waves stretched. You already know this effect from daily life. It is the same physics that makes an ambulance siren rise in pitch as it approaches and drop as it recedes. The universe's oldest light has a pitch, and for us, the pitch rises toward the constellations of the southern sky and falls behind us. We are moving through the afterglow. The warm patch ahead is our bow wave. And from the size of that warmth, barely a few thousandths of a degree, the speed can be read off directly. The sun, carrying the Earth and you, is traveling at about 370 kilometers per second relative to the universe's own rest frame. And once you subtract our orbit around the galaxy's center, The Milky Way itself is moving at roughly 600 kilometers per second, about 2.1 million kilometers per hour, toward a point in the sky between the southern constellations of Centaurus, one of Physics, Authis. Hold on to the strangeness of this for a second before we move on. The most ancient light in existence, released before a single star had ever formed, is warm on one side of our sky because the galaxy you live in is falling through it, like a face feeling the wind. Every one of us wears that wind, every moment of our lives, and never once feels it. That is our first piece of evidence, the direction and the speed. Now comes the reason those numbers shocked people, because in the 1970s and 1980s, when this motion was first measured properly, it directly contradicted what everyone believed the universe was supposed to be doing. Here is what everyone believed, and it was not foolish. It was the great discovery of the 20th century. The universe is expanding. Space itself stretches, and it carries the galaxies apart the way rising raisin bread carries its raisins apart. No raisin swims through the dough, but every raisin sees every other raisin receding, and the farther the raisin, the faster it recedes. In a perfectly smooth, expanding universe, that is the whole story. Galaxies do not go anywhere. They are carried. Their motion should be pure drift, outward with the dough, in every direction equally, with no galaxy singled out, no preferred destination, no falling toward anything. So when the measurements said the Milky Way possesses, on top of the expansion, its own private motion of 600 kilometers per second aimed at a specific spot, the implication was immediate and uncomfortable. Something in that direction is not smooth. Physicists call this kind of private motion a peculiar velocity. Peculiar in the old sense of belonging to oneself, and peculiar velocity has exactly one known cause: gravity. Somewhere in the dough ahead of us, there is a lump, an overdensity, a region where matter has gathered so thickly that its gravity fights the expansion, reaching across the stretch of space and reeling nearby galaxies inward. The size of the peculiar velocity tells you about the size of the lump, and this is where the numbers began to frighten people. Because to move an entire galaxy at 600 kilometers per second, and not just our galaxy, as we will see, but a whole flock of galaxies around us, the lump had to be enormous beyond anything then catalogued. The mass of tens of thousands of Milky Ways, tens of quadrillions of suns, concentrated in one region of the sky, roughly 150 to 250 million light-years away. Nothing on the maps of that era came close. The universe was not supposed to be that lumpy. And so, by the mid-1980s, astronomy found itself in the position of a detective who had measured the footprints, calculated the weight of the intruder, and realized that nothing in the neighborhood registry could possibly have made them. The hunt for the Great Attractor had begun. And since a good detective always reconstructs the full itinerary of the subject, let us do that now, properly, because your motion tonight is not one motion. It is a ladder of motions, nested inside one another like wheels within wheels, and climbing that ladder rung by rung is the best way I know to feel what the word falling really means by the time it reaches galactic scale. Start at the bottom rung, in your bedroom. The Earth is spinning, and unless you live near a pole, its rotation is carrying you eastward right now at hundreds of kilometers per hour, faster than most airliners near the equator, a carousel the size of a world turning once a day. Climb one rung. The spinning Earth is also orbiting the Sun, and this motion is of another order entirely, 107,000 kilometers per hour, 30 kilometers every second. Since you began this video, you have traveled farther around the Sun than the diameter of the Earth. In the time it takes you to fall asleep tonight, you will cross a distance greater than from the Earth to the Moon, and you make this commute every single night of your life without spilling a glass of water. Climb again. The Sun, carrying its whole family of planets, is orbiting the center of the Milky Way, swinging around the galaxy's core at about 828,000 kilometers per hour, 230 kilometers per second, a lap so vast that it takes roughly 230 million years to complete. The last time the Sun stood where it stands tonight relative to the galaxy's center, the dinosaurs had not yet risen. The entire age of the dinosaurs, their rise, their long reign, and their ending fits inside a single one of these galactic years, and the Sun has completed about 20 of them in its lifetime. And now the top rung, the one this whole case is about. The Milky Way itself, carrying the Sun's orbit, carrying the Earth's orbit, carrying the Earth's spin, carrying your stillness, is moving through the rest frame of the universe at 600 kilometers per second toward Centaurus and Norma. Stack the latter together, and the accounting becomes almost comical. You, lying motionless, are executing 4 enormous motions simultaneously, each one nested in the next, spinning while orbiting, while circling, while falling. And the sum, the honest total of your velocity through the cosmos tonight, is around 2 million kilometers per hour. You will travel roughly 50 million kilometers in your sleep tonight. You have never once felt any of it, and later in the file, we will see the profound reason why. But there is one more rung I skipped, the most local fall of all, and it deserves its own moment, because it is the only one on the ladder with a destination we will actually reach. Between the sun's orbit and the galaxy's great plunge, there is a smaller, more intimate current. The Milky Way and its nearest giant neighbor, the Andromeda Galaxy, are falling toward each other. Andromeda is 2.5 million light-years away, a spiral somewhat grander than our own, and it is one of the very few galaxies in the entire sky whose light arrives blue-shifted, compressed, approaching, cutting against the universal recession of everything else. The two galaxies are closing at about 110 kilometers per second, drawn by their mutual gravity across the gulf. And here, unlike the grand fall toward Shapley, dark energy will not intervene. The pair is close enough and bound tightly enough that the expansion of space cannot save them from each other. In roughly 4 to 5 billion years, by the standard projections, the two spirals will sweep together, pass through each other in a slow gravitational embrace, swing apart, return, and over the following eons settle into a single merged galaxy, their stately spiral architectures dissolved into one vast elliptical swarm of 1 trillion stars. It sounds like an apocalypse, and is almost the opposite. The stars within galaxies are spaced so absurdly far apart relative to their sizes that in the entire merger of nearly 1 trillion suns, the expected number of direct stellar collisions is approximately 0. The galaxies will pass through each other the way 2 clouds of gnats pass through each other on a summer evening, interleaving without touching. The night skies of any worlds that survive to watch will be magnificent, Andromeda swelling over millions of years from a faint smudge to a sky-spanning river of stars, the 2 galactic cores blazing like twin moons of light, and then, slowly, a new combined galaxy assembling itself around the survivors. I include this rung in our reconstruction for one reason: it proves, close to home, that galaxies really do fall. The great current toward the attractor can feel abstract, a story told in statistics and microwave temperatures. Andromeda is not abstract. It hangs in our autumn sky, visible to your naked eye from any dark field, the most distant object human vision can perceive unaided, and it is coming here. When you look at it, you are looking at gravity operating on the same principle as our whole case file. At a range near enough to touch, mass calling to mass across the void, patient beyond all human patience, and always, in the end, collecting. And there is one more figure who belongs in this reconstruction, a detective who worked the case before the case officially existed, and whose treatment is a lesson the field has not forgotten. In the early 1950s, and again in the 1970s, the astronomer Vera Rubin, whose name you may know from the discovery that made dark matter unavoidable, presented evidence that the galaxies of our region were not simply riding the smooth universal expansion, that there were large-scale streaming motions, coherent drifts of galaxies across enormous volumes of the sky. Her first such work was presented when she was a young researcher, and the reception was brutal. The result was dismissed, the journals declined it, and senior figures assured her that the universe at those scales was smooth and quiet, that galaxies did not gang up and flow. Decades later, with collaborator Kent Ford, she found the signal again in a careful study of distant spiral galaxies, an anomalous motion of our neighborhood that came to be called the Rubin-Ford effect, and again the community pushed back hard. The claimed flow was in an awkward direction. The methods were questioned, and the results spent years in the wilderness of interesting if true. The specific numbers of those early studies did not survive unchanged. The modern maps redrew the details. But the heresy at the heart of them, that our corner of the universe is streaming coherently under the pull of distant concentrations of matter, turned out to be precisely correct, vindicated in full by the 7 Samurai and everything after. The lesson sits in the file as a caution and a comfort. The universe is under no obligation to match our sense of tidiness. The messengers of its lumpiness are often doubted first and honored later. And some of the greatest discoveries in this story were made by people who kept measuring after being told the answer was already known. I owe you one small story from the early days of the file, because the first clean measurement of our motion was made with equipment so improbable that it sounds invented. In the mid-1970s, a young physicist named George Smoot and his colleagues needed to measure the temperature of the microwave sky with exquisite precision from above the blurring, glowing atmosphere, and satellites for such work did not yet exist. So they borrowed something that did, a U-2 spy plane, the same aircraft built to photograph military secrets from the edge of space, flying higher than any airliner, above 95% of the air. The team fitted the plane with a radiometer looking up instead of cameras looking down, and night after night, the converted spy plane carved arcs over California, comparing the warmth of one patch of sky against another, hunting for a difference of a few thousandths of a degree. And it found one. The sky was warmer toward the constellation Leo and cooler behind, in a smooth pattern spanning the heavens, exactly the bow wave signature of motion through the afterglow. When the team announced in 1977 that the Milky Way was rushing through the universe at hundreds of kilometers per second, faster and in a stranger direction than anyone expected, the results surprised even them. Smoot later admitted they checked everything, including whether the plane itself was somehow fooling them, before they believed it. The measurement has since been repeated by balloons, by mountaintop instruments, and by 3 generations of satellites, each more precise than the last, and it stands today as the anchor of this entire case. The fall was first charted by a spy plane that spent its career keeping earthly secrets, moonlighting at night to give away a cosmic one. There is a lesson in the instrument itself. The discovery required no new physics and no giant telescope, only the willingness to measure an old glow more carefully than anyone had bothered to, and one of the largest facts about our existence, the direction and speed of everything we are, was hiding in the 3rd decimal place of a temperature. The universe keeps some of its grandest secrets not behind complexity, but behind precision. Every case needs its detectives, and this one had a squad so memorable that astronomy still calls them by their nickname. In the mid-1980s, 7 astronomers from institutions around the world, David Burstein, Roger Davies, Alan Dressler, Sandra Faber, Donald Lyndon Bell, Roberto Terlovich, and Gary Wegner joined forces to attempt something that had never been done, a 3-dimensional map, not of where the nearby galaxies are, but of how they are moving. Their colleagues, half in admiration and half in tease, named them the 7 Samurai. Understand the difficulty of what they attempted. Measuring how fast a galaxy recedes from us is easy. Its light is stretched by the expansion, reddened in proportion to its speed, and a spectrograph reads it off in an evening. But that number blends 2 things, the honest expansion of space and the galaxy's private, gravity-driven, peculiar motion. To separate them, you must know the galaxy's true distance independently, so you can calculate what its recession speed ought to be from expansion alone, and then subtract. Whatever is left over is the peculiar velocity, the fingerprint of hidden mass. And measuring true distances to galaxies is one of the hardest crafts in astronomy. The 7 Samurai spent years developing and applying a method that used the internal physics of elliptical galaxies, the relationship between how big such a galaxy truly is and how fast its stars swarm inside it, to estimate honest distances to about 400 galaxies spread across the sky. Then they subtracted and looked at what remained. What remained made the room go quiet. The peculiar motions were not random. Across a vast stretch of the local universe, galaxies were streaming coherently, like leaves on a river, all drifting toward the same region of the southern sky, the same region our own microwave speedometer points to, between Centaurus and Norma. It was not just the Milky Way falling. It was everyone. Our entire neighborhood of the universe, our galaxy, the Andromeda Galaxy, the whole local group, the Virgo cluster with its thousands of galaxies and thousands upon thousands of systems beyond it, all caught in the same current, all sliding toward one unseen drain. In 1987, when the team announced the result and one of them coined the name Great Attractor for whatever waited at the bottom of the flow, the reaction from much of the community was polite disbelief. the claimed mass was too large. The coherence of the flow was too eerie. Rival teams checked for errors in the distance method, argued about statistics, and mounted their own surveys, which is exactly what science is supposed to do to an extraordinary claim. And the surveys came back, one after another, saying the same thing. The river was real, which brought the investigation to its most maddening chapter, because now that astronomers knew precisely where to look, they pointed their best optical telescopes at the destination of the flow, the patch of sky that should contain one of the mightiest structures in the visible universe, and they found the view blocked. Not by distance, not by darkness, by home. The direction of the Great Attractor lies almost exactly behind the disk of our own Milky Way. Let me make sure you feel the full absurdity of this, because it is one of my favorite ironies in all of science. The Milky Way is a flat disk, and we live inside it, about 2/3 of the way out from the center. When we look up and out of the disk, the view is clean. We see deep space, distant galaxies, the wide universe. But when we look along the disk, edgewise through our own galaxy, we are looking through hundreds of billions of stars and vast banks of dust, the thick of our own city. Optical astronomers have an old name for that strip of sky, the zone of avoidance, the band, covering roughly a fifth of the heavens, where the study of other galaxies was simply abandoned for a century because our galaxy's dust curtains it off. Visible light from behind the disk is absorbed and scattered before it ever reaches us. In the densest lanes, only one photon in trillions survives the crossing. And the Great Attractor, the destination of the mightiest river of galaxies ever charted, the object powerful enough to pull the Milky Way itself, sits behind that curtain. Think about what this means. The thing is not hiding in the sense of being far away or faint. By cosmic standards, it is practically next door, and it is titanic. If the Milky Way's dust were removed, the core of the attractor region would be one of the richest fields of galaxies in our entire sky. We cannot see it for the same reason you cannot see the mountain range on the far side of your own city on a smoggy day, not because the mountains are small, but because you live in the smog. The universe, with a comedian's timing, parked its greatest local monument exactly behind the one strip of sky we cannot look through. So, the investigation did what all good investigations do when the front door is locked. It went in through the walls, because dust is only opaque to the light our eyes use. Longer waves slip past dust grains untouched, the way ocean swells roll past a pier's pilings while ripples are stopped. Infrared light penetrates the curtain. Radio waves sail through it as if it were glass. And X-rays, the signature of the hottest gas in the universe, punch through as well. Beginning in the 1990s, astronomers turned these other eyes toward the zone of avoidance, and the curtain began, for the first time in history, to open. What they found behind it was a metropolis. Slowly, survey by survey, a great structure assembled itself on the maps, a dense knot of galaxies in the constellation Norma, right at the heart of the flow's destination, a cluster now called the Norma Cluster, one of the most massive gatherings of galaxies in the nearby universe, anchoring a long wall of clusters and filaments, thousands upon thousands of galaxies, threaded through exactly the region the rivers of motion had pointed to for a decade. Radio surveys, which detect the cold hydrogen gas in galaxies regardless of dust, filled in hundreds more systems that no optical telescope had ever recorded. Entire galaxies, each with its billions of stars and, statistically, its billions of planets, that had been sitting behind our smog unlisted in any catalog, and X-ray telescopes confirmed the deep signature of a true giant, vast reservoirs of gas heated to tens of millions of degrees, pooled in the gravitational wells of the clusters, glowing where visible light could never escape. Here, at last, was a suspect worthy of the crime, a genuine supercluster, the mass of many thousands of Milky Ways, near enough and heavy enough to bend the motions of its neighbors. Case closed, you might think. The seven samurai vindicated, the attractor unmasked, the file stamped and shelved. And for a short while in the 1990s, some astronomers thought exactly that. But the best investigations have a second act, and this one arrived the way second acts always do. Someone did the accounting, and the numbers did not balance. When astronomers carefully weighed everything they had found behind the curtain, The Norma cluster, the walls, the filaments, the hot gas, and added generous allowances for what dust might still be hiding, the total came to only a fraction of the mass required to explain the river. Something like half, or less, of the pull was unaccounted for. The galaxies were falling harder than the visible suspect could explain. The Great Attractor, it turned out, was real, but it was not the whole answer. It was the henchman, and the search for the true mastermind would have to look deeper, much deeper, into the darkness beyond it. To find the mastermind, the investigators had to raise their eyes past the attractor itself and ask a question that had been waiting quietly in the data all along. Is the river of galaxies slowing down as it approaches the Great Attractor, the way water slows into a pool, or does it keep flowing straight through? Because those two behaviors tell completely different stories. If the attractor is the true bottom of the valley, galaxies near it should be settling, their streaming motion dying away as they arrive home. But if the current continues past it, if even the attractor region itself is moving, then the attractor is not the destination. It is merely a waypoint, a heavy passenger on a train bound somewhere further. Through the 1990s and 2000s, as distance measurements improved and surveys reached deeper, the answer sharpened, and it was the second one. The flow does not stop at the Great Attractor. The attractor region, with all its thousands of galaxies, is itself streaming onward toward a point deeper in the same quarter of the sky. And when astronomers followed that line, another 400 to 500 million light-years outward, they arrived at something that dwarfs everything we have discussed tonight. It is called the Shapley Supercluster, named for the astronomer Harlow Shapley, who first noticed, all the way back in 1930, a remarkable fog of faint galaxies in the constellation Centaurus, a discovery so far ahead of its time that it sat in the archives for half a century, waiting for the rest of the field to need it. The Shapley Supercluster is the single most massive known structure in our corner of the universe, a gathering of dozens of rich galaxy clusters, more than 8,000 cataloged galaxies, and a total mass estimated at 10,000 trillion suns, roughly the weight of 10 million Milky Ways gathered into one gravitational metropolis, some 650 million light-years from your bedroom. Seen on the great maps of the cosmic web, our whole region of the universe leans toward it, the way iron filings lean toward the pole of a magnet. The modern accounting suggests the pole on the Milky Way is a shared enterprise, a large share from the Great Attractor region and its walls, and a comparable or greater share from Shapley and the structures around it, all lined up, by cosmic coincidence, in nearly the same direction, so that their poles add. We are not falling toward one thing. We are falling down a corridor of giants, each handing us onward to the next. And yet even this, the discovery of the mastermind, did not close the file. Because in 2017, a team of cosmologists mapping the flows of 10,000 galaxies announced the final twist, the one nobody had written into the plot. They had been asking, all along, what pulls us. No one had thought to ask what pushes. Here is the insight, and it is so simple that once you hear it, you will wonder, as the experts did, why it took 30 years to say out loud. Gravity's influence on the cosmic rivers has two signatures, not one. A great mass pulls galaxies toward itself, flows converge on it. But a great emptiness, a void, a region with far less matter than average, does the opposite. It does not push in any literal sense. Nothing reaches out from a void. Rather, a galaxy sitting between a void and the average universe is pulled by everything except the void, and the imbalance moves it away from the emptiness exactly as if the void were repelling it. In the ledger of motions, a deficit behaves like a negative mass. Absence, in an expanding universe, is a force. So the team, led by cosmographers who had spent decades charting the local flows, reconstructed the full three-dimensional velocity field of our cosmic neighborhood and looked not only for the drains, the attractors where streams converge, but for the sources, the regions the streams all flee. And there it was, almost exactly opposite the Shapley concentration on the sky, in the direction we are moving away from. They found an immense region, hundreds of millions of light-years across, nearly empty of galaxies, from which the flow lines radiate outward like water from a fountainhead. They named it the dipole repeller. And with that discovery, the case of the Milky Way's motion finally assembled into a complete picture, and it is a picture of almost poetic balance. We are not simply falling, We are fleeing and falling at once. Behind us, one of the greatest emptinesses in the nearby universe, an ocean of missing matter releasing us outward. Ahead of us, the corridor of giants, Norma, the Great Attractor walls, and the vast harbor of Shapley reeling us in. Push from the void, pull from the crowd, the two aligned along a single axis through the sky, and our galaxy, with you aboard, riding the current between them at 2 million kilometers per hour. The measurement that started this case, that faint warmth on one side of the oldest light in the universe, turns out to be the wake of a journey between an emptiness and an empire. And now that the suspects are named, we owe the case one more honest layer, because everything I have described, the clusters, the walls, the shining metropolises of galaxies, is only the visible tip of the machinery. When astronomers weigh these great structures properly, using the speeds of the galaxies swarming inside them, the temperature of their X-ray gas, and the way their gravity bends the light of galaxies far behind them, an effect Einstein predicted, where mass acts as a lens and distorts the images passing near it, the totals always come out the same way, 5 to 6 times heavier than all the stars and gas combined. The pull that moves the Milky Way is mostly not coming from anything that shines. It comes from dark matter, the invisible substance whose gravity sculpts the universe, gathered into the same clusters and filaments as the galaxies, or rather, and this is the more accurate way to say it, the galaxies are gathered into it. On the largest scales, the luminous universe is froth riding on dark currents. The cosmic web itself, the network of filaments and knots and voids that fills all of space like a three-dimensional spider's web, is first and foremost a web of dark matter, woven by gravity out of tiny ripples in the newborn universe, over 13 billion years of patient amplification. The galaxies merely decorate it, streetlights strung along invisible highways. So when you ask what could be powerful enough to pull an entire galaxy, the truthful answer has a hierarchy. Approximately, superclusters, the Great Attractor region, and Shapley. Fundamentally, dark matter, which outweighs everything we see 5 to 1 and holds the deed to every structure on the map. And architecturally, the pattern itself, the web of overdensity and void, laid down in the universe's first instance, of which our 2 million kilometer per hour journey is simply one local reading. You are not being pulled by a thing, so much as by a landscape. The Milky Way is a drop of water on a vast tilted terrain, and it is doing what water does. It is finding the valley. Which brings us to the name that finally organized all of this into a single idea, one of the most beautiful concepts in modern cosmology, and it came from thinking about rain. In 2014, the same school of cosmographers, who would later find the dipole repeller, proposed a new way to answer an old, surprisingly slippery question. Where do we live? Not our address in the sense of coordinates, but our address in the sense of belonging. What structure is the Milky Way actually a part of? For decades, the answer was vague. We belong to the local group, our small family of galaxies with Andromeda. The local group loiters in the outskirts of the Virgo cluster's domain, so we were said to live in the Virgo Supercluster. But the borders of that supercluster were drawn by eye, by circling crowded regions on maps, the way one might circle city lights in a night photograph, and everyone knew the borders were arbitrary. The 2014 team proposed something better. Forget where the galaxies are, they said. Ask where they are going. On Earth, we do not define a river basin by drawing circles around towns, we define it by the flow of water. Every drop of rain that falls within the Mississippi watershed, wherever it lands, will find its way to the same river. The boundary of the watershed is the divide. The ridgeline, where a drop falling 1 meter to the left goes to one river, and a drop 1 meter to the right goes to another. The team applied exactly this logic to the universe. Using their maps of galaxy motions, they traced the flow lines of thousands of galaxies, following each one downhill along its gravitational current, and asked which galaxies drain toward the same basin. The answer drew, for the first time, a natural border around our home. It encloses a region about 520 million light-years across, containing roughly 100,000 galaxies, with a combined mass of about 100 quadrillion suns, all of whose motions bend toward the same interior valley, and the bottom of that valley, the drain of our entire cosmic watershed, is the Great Attractor region. They named the watershed Laniakea, a Hawaiian word meaning immense heaven, chosen to honor the Polynesian navigators who crossed oceans by reading stars. That is your address, the true one, the one written by gravity itself. You live in the Laniakea Supercluster, in the suburbs, far out near the border, and the 2 million km/h motion we have spent tonight investigating is simply the sound of your neighborhood draining toward its river. And the map came with a revelation about our position that reframes everything. We are not central. We are peripheral in the most literal sense. The Milky Way sits close to the edge of Laniakea, near the divide, the ridgeline where our watershed meets the next one over, a neighboring basin that drains toward the Perseus and Pisces clusters in the opposite part of the sky. Galaxies barely farther from us, cosmically speaking, are falling the other way, toward rivers we will never join. 2 drops of rain on the 2 sides of a rooftop. That is how close the universe came to sending us somewhere else entirely. So we are falling, and now we know toward what and why, and the case wants only its final question, the one every falling thing eventually asks: will we land? Will the Milky Way, someday, actually arrive at the Great Attractor, plunge into the Norma cluster, merge into the metropolis at the bottom of our watershed? Here, the investigation delivers its quietest and strangest verdict. No, we will never arrive. And the reason is the second great force shaping the universe, the one that has been waiting politely offstage all night. In 1998, astronomers measuring distant exploding stars discovered that the expansion of the universe is not slowing down under gravity's brake, as everyone expected, but speeding up, driven by something woven into space itself, an energy of the vacuum which received the placeholder name dark energy and has kept it. Because a quarter century later, we still do not know what it is. Whatever it is, it holds the majority stake in the universe, about 2/3 of the total energy of everything, and its effect is simple and absolute. With every passing eon, space stretches faster, and any 2 objects not already bound tightly together by gravity are carried apart at an ever-increasing rate. Now apply that to our fall. The Great Attractor is 150 to 250 million light-years away. At 600 kilometers per second, the Milky Way would need on the order of 100 billion years to cross that distance, 10 times the current age of the universe. But we do not have 100 billion years, because while we fall toward the attractor at 600 kilometers per second, the stretching of space between us and it is carrying it away faster than we approach, and the gap is widening, and dark energy guarantees the widening will only accelerate. Our fall is real. Our arrival is impossible. The current that carries us is a river flowing across a landscape that is itself being stretched apart faster than the water can run. Cosmologists have run the film forward, and the ending is now considered secure. Laniakea, our immense heaven, is not gravitationally bound. It is a watershed drawn on a floodplain during the flood. Its 100,000 galaxies will never gather at the drain. They will be carried from one another, basin and river, and divide, all dissolving into the accelerating dark, until, in the deep future, each little bound archipelago, ours is the local group, the Milky Way and Andromeda and their attendants, is left utterly alone in an empty sky. The fall we investigated tonight is a gesture the universe will never allow to finish, which sounds melancholy until you turn it over. It means the structure we discovered, the rivers, the watershed, the corridor of giants, is not a permanent architecture but a moment, a pattern of currents visible only now, in the universe's green and flowing youth, to observers lucky enough to exist before the flood carries the map away. We happen to be born in the narrow age when the address Laniakea means something. Astronomers 100 billion years from now, if there are any, will look out on blackness and never know the empire and the emptiness that once played tug-of-war with their galaxy. We know. The case file is ours to keep. Before we close the file, there are 3 loose threads on the desk, and each one is a small case of its own, worth working while the night is still deep. The first is a question you may have been holding since the beginning. If all of this is true, if the Earth is spinning, orbiting, circling the galaxy, and plunging through the afterglow at 2 million kilometers per hour, why do you feel nothing? Not approximately nothing. Nothing. The stillness of your bedroom is not an illusion of dull senses. The finest laboratory instruments on Earth, sensitive enough to detect the trembling of atoms, also register no trace of our 2 million kilometer per hour flight. The answer was found by Galileo 4 centuries ago and sharpened by Einstein into the foundation stone of modern physics. Uniform motion is undetectable from the inside, and free fall, motion under gravity alone, is the most uniform motion there is. A ship gliding on calm water, a plane in smooth air, a planet in orbit, a galaxy in a cosmic current inside each one, every experiment behaves exactly as it would at rest, because motion shared perfectly by everything around you is, physically, indistinguishable from stillness. And Einstein went further, into one of the deepest statements ever made about nature. Falling freely under gravity is not merely undetectable, it is the natural state, the truest version of rest that exists. An astronaut falling around the Earth floats. A galaxy falling toward Shapley coasts. You, tonight, falling with the Milky Way down the long slope of Lani Akea, are not a passenger being dragged. You are, in the strict physical sense, at rest. More perfectly at rest than anything bolted to a spinning planet has any right to feel. The stillness you feel in your bed is not ignorance of the fall, it is the fall. Peace and plunge, in this universe, are the same condition experienced from inside. The second thread is about trust. How confident are we really in this whole edifice, the rivers and attractors and repellers, given that the central player hides behind our own galaxy? It is a fair challenge, and the investigation has answered it the way strong cases are always answered, with independent witnesses. The motion itself is measured in the microwave background to a precision beyond doubt. That warmth in the sky ahead of us is one of the most accurately measured numbers in all of cosmology. The flow of the galaxy rivers has now been mapped by successive generations of surveys, using different distance methods, different telescopes, different teams with every incentive to prove each other wrong, and the currents persist through all of them. The mass behind the zone of avoidance has been confirmed in wavelengths that do not care about dust, in the 21-centimeter whisper of cold hydrogen, in the X-ray shine of 100 million degree cluster gas, in infrared surveys that catalog the hidden galaxies one by one, and in recent years by gravitational lensing, gravity's own testimony, which weighs the unseen directly by how it bends light from beyond. Even the dipole repeller, the boldest claim in the file, has been tested by checking that the void it requires truly is empty in the deepest galaxy counts we possess, and so far, the emptiness holds. Science never stamps a case closed forever. The exact division of pole between the attractor and Shapley is still argued in the journals, the precise depth of the repeller still being sounded. But the architecture, the fact of the fall, its direction, its causes, and the push of absence and the pull of gathered dark matter, now rests on so many independent lines of evidence that overturning it would require not one error, but a conspiracy of unrelated errors, all pointing the same way. In the courtroom of cosmology, that is called proof beyond reasonable doubt. The third thread is the one that turns the case personal, and I have saved it for the end of the evidence on purpose. Everything in this file happened before, at another scale, and the result of that earlier case is you. The same physics that gathers superclusters, tiny early ripples of density, amplified by gravity, drawing matter down the slopes into the valleys, is the physics that built the Milky Way itself, and the Sun and the Earth. Once, about 4.5 billion years ago, a cloud of gas and dust in one filament of the web, enriched by the deaths of earlier stars, lay at the top of its own small watershed. It fell. It drained down its own gravitational valley, gathering, spinning, warming, until a star lit at the bottom of the fall and a scatter of leftover stones settled into orbits around it, and one of the stones cooled its skin, pooled its water, and eventually grew a creature that lies in the dark listening to the story of falling things. Falling is not a fate that happens to the universe's contents. Falling is the process that makes the contents. Every structure you have ever seen, every mountain, every ocean, every face, sits at the bottom of some ancient completed fall, and every fall still in progress, including the great one we investigated tonight, is the universe in the act of making its next things. When you feel gravity press you gently into your mattress right now, you are feeling the local, domesticated version of the very force that is drawing 100,000 galaxies down the valley of Lani Akea. It is one phenomenon, one law, one habit of the cosmos, operating in your bedroom and across 500 million light years in the same instant with the same quiet patience. There is a chapter of the investigation I have been holding back because it belongs here, at the moment of judgment, and it concerns the years when the whole case nearly fell apart. In the 1990s, after the Norma cluster was found and the Great Attractor had a face, a rival school of astronomers mounted the most serious challenge the hypothesis ever faced, and their weapon was a beautifully simple test. If the Great Attractor is truly a great mass, they argued, then galaxies on the far side of it should be falling back toward it, toward us, their motion reversed relative to the general flow. The pattern is called backside infall, and it is the smoking gun of any true attractor, streams converging from both sides, like water approaching a drain from every direction. So the challengers measured distances and motions for hundreds of galaxies beyond the attractor region, and announced that they could find no backside infall at all. The river, they claimed, flowed on past the supposed drain without pause, which would mean the Great Attractor was a mirage, a mere way station, and the true source of our motion lay much farther away, perhaps entirely in the Shapley direction. For several years, the field genuinely split. Conferences hosted duels of data. The distance measurements at those ranges were fiendishly delicate. The zone of avoidance contaminated everything, and both camps could point to weaknesses in the other's method. The resolution, when it came, arrived the way resolutions usually do in astronomy, not with a single decisive strike, but with better instruments slowly drowning the ambiguity. Deeper surveys refined the flow maps and found the truth was, in the most satisfying way, both there is genuine mass and genuine convergence at the Great Attractor region, and the flow also genuinely continues beyond it toward Shapley. The drain is real, and it sits partway down a longer slope. The modern picture keeps both camps' insights, and the episode earned its place in the file as a reminder that in science, a fierce, decade-long argument is not a malfunction. It is the machine working. That episode also forces the question that shadows this entire case, and I want to answer it directly, because it is the question a good skeptic in your position should be asking. How do you weigh something you cannot see? How can anyone claim the Shapley concentration holds 10,000 trillion solar masses, or that the attractor region holds tens of thousands of Milky Ways, when most of that mass is invisible and half of it hides behind our own galaxy's dust? The answer is that astronomers have three independent scales, and the whole case rests on the fact that they agree. The first scale is motion itself. Inside a cluster, galaxies swarm like bees, and the speed of the swarm is set by the depth of the gravitational well. Measure the speeds, and the well tells you its mass, a method so old it was the very technique by which Fritz Zwicky in the 1930s first noticed that clusters weigh far more than their light suggests. The second scale is heat. The space between a cluster's galaxies is filled with thin gas heated to tens of millions of degrees, precisely because it is compressed in the cluster's gravitational grip. The temperature of that gas, read directly from its X-ray glow, is a thermometer that doubles as a scale, and it penetrates the dust curtain effortlessly. The third scale is light bending. Mass curves the paths of light passing near it, so a massive cluster subtly distorts the shapes of the thousands of faint background galaxies behind it, stretching them into faint arcs and alignments. And by measuring the distortion pattern, astronomers weigh the cluster using gravity's own signature, with no assumptions about what the mass is made of or whether it shines. Motion, heat, and lensing, three scales built on unrelated physics, wielded by different instruments, and when they are pointed at the same structure, they return the same verdict within their uncertainties. That triple agreement is why the masses in this file are trusted, and it is also, incidentally, among the strongest evidence in all of science that dark matter is real. Three unrelated scales all report mass that the starlight cannot account for in the same places in the same amounts. And the file, I should tell you honestly, is still growing. In 2016, a team surveying the zone of avoidance announced the discovery of yet another giant that had been hiding behind the curtain all along, a previously unknown concentration of galaxy clusters, now called the Vela Supercluster, sitting some 800 million light-years away in the direction of the constellation Vela, its heart crossing almost exactly the thickest, most opaque part of the Milky Way's disk. Early estimates suggest it may be massive enough to contribute its own share to the motions of our neighborhood, a share not yet fully counted in anyone's ledger, and surveys are still, tonight, as you listen, patiently charting its extent through the dust. Think about what that means. In the third decade of the 21st century, with the sky mapped by satellites and surveyed by robotic telescopes every clear night, it is still possible for a structure of hundreds of thousands of galaxies, one of the largest objects in the nearby universe, to be substantially undiscovered, screened from our eyes by the glowing streets of our own hometown. The map of our cosmic neighborhood is not finished. The census of the giants that pull us is still open. Somewhere behind the soft band of light that crosses your sky on a dark summer night, there may be further empires, uncounted and unnamed, already written into the motion of your galaxy, waiting for some future survey, some future graduate student squinting at anomalies, to give them their place in the file. Our case tonight closes with a verdict, but not with an ending. The best cases never quite end. One more entry belongs in the reconstruction before the verdict, because we have been speaking of currents and rivers all night, and it is worth pausing to describe the landscape the rivers cross, the terrain itself, since it is quite likely the largest single pattern you will ever have described to you. If you could rise out of the Milky Way, out of Laniakea, out beyond the reach of any real voyage, and look back at the universe on the grandest scale our maps reach, you would not see galaxies scattered like salt spilled at random. You would see a web. Matter on the largest scales arranges itself into an immense three-dimensional filigree, long luminous filaments of galaxies, tens to hundreds of millions of light-years in length, meeting at dense knots where the great clusters sit, framing colossal dark cells of emptiness. The voids, which occupy most of the volume of the cosmos while containing almost none of its substance. The structure resembles nothing so much as a sponge, or the foam of soap bubbles, or, in an analogy that has unsettled and delighted people in equal measure, the network of neurons in a brain, bright threads, junctions, and hollow chambers, repeated in every direction as far as any survey has ever reached. Our entire case tonight has been played out on this terrain. The Great Attractor is a junction where filaments meet. Shapley is one of the mightiest knots on the map. The dipole repeller is one of the hollow chambers. Laniakea is a province of threads that happen to drain toward a common junction, and the Milky Way is a bead of light partway along one thread, sliding slowly toward the knot at its end. And the deepest fact about this web is where its pattern came from. Run the universe backward, and the filaments and voids shrink into faint ripples, variations of a part in 100,000, printed across the newborn cosmos in its first moments, ripples we can still read directly today, frozen into that same microwave afterglow that serves as our speedometer. Every knot, every thread, every chamber of the web is one of those primordial whispers, amplified by 13.8 billion years of gravity's compound interest. The current that carries your galaxy tonight was, in its first draft, a fluctuation smaller than a rounding error, written before there were atoms. The universe does not improvise its architecture. It develops a photograph taken at the beginning of time, and the developing fluid is gravity, and the exposure is still going on. So let us close the file the way detectives do, by reading the summary aloud one last time in the empty office. The victim, if we can call it that, was our sense of stillness, the discovery that the Milky Way, far from drifting passively with the expansion of space, is racing at 2.1 million kilometers per hour toward a point between Centaurus and Norma. The first clue was the oldest light in the universe, warmed ahead of us and cooled behind us by our own motion, the afterglow of creation doubling as a speedometer. The first detectives were 7 astronomers who mapped the motions of galaxies and found not chaos, but a river, an entire region of the cosmos streaming coherently toward an unseen mass they named the Great Attractor. The obstruction was the zone of avoidance, our own galaxy's dust, hiding the culprit behind the one curtain we cannot pull aside until infrared, radio, and X-ray eyes went through the wall and found the Norma cluster and its wall of galaxies waiting exactly where the river pointed. The twist was the accounting. The visible suspect was too light, the flow continuing past it, leading the investigation onward to the true heavyweight, the Shapley Supercluster, 10 million Milky Ways of mass anchoring the deep end of our sky. The second twist was the discovery that absence acts too, the dipole repeller, a great void behind us, releasing us toward the crowds ahead, push and pull aligned along one axis through the heavens. The resolution was a new map and a new address, Laniakea, the watershed of 100,000 galaxies whose flows all bend toward the same drain, with our galaxy perched near its border, and the verdict was rendered by dark energy: the fall is real and the arrival is cancelled, the river flowing across a floodplain that is stretching faster than the water runs, so that we live in the brief bright age when the map still means something. And the closing note, added in pencil at the bottom of the last page, is the equivalence that Einstein taught us, that this whole immense plunge is, from the inside, indistinguishable from perfect rest, and that falling and floating are one word in the universe's own language. So here is the truth to carry with you as you drift off tonight. You are lying still, and that is true. You are crossing 600 kilometers of space every second toward an empire of galaxies you will never reach, fleeing in emptiness you will never see, and that is also true. And the deepest law of physics says these two truths are not in conflict, because gravity's falling is creation's method and stillness is its feeling from within. Somewhere ahead of you, hidden behind the soft band of the Milky Way that crosses your summer sky, the drain of our watershed waits, patient and unreachable, and the current carries the whole neighborhood on. Let it carry you too. It has been carrying you your entire life, and it has never once woken you. If tonight's investigation kept you in good company, a like or a subscribe genuinely helps this channel keep working cases like this one, and it means more than you know. The universe will still be strange in the morning. Good night.